me show it once again. Set working directory, choose working directory, and if it is there in the desktop, in my case it is, which one is there? It is research paper co-integration. Here I have. So you must be having your own working directory folder. So you select that. Okay, done everyone? First step. Do not skip this step. Next. Next is, what is the next thing that I need to do to get the data into my environment? We have done this several times. Tell me what to do next. We need to load the package called read Excel because it is already installed. So read Excel. So just run this library read Excel. Everyone, please do it. Library read Excel, right? And then we need to install and load some other packages. So I'll just give all these codes in the group right away. So those who join late also, so that they can do it easily, right? So let me just put it in the group. Okay. So I have given it in the group. Please check that. And I told you the last class how to install many packages in one go. So you can use this. You can create a vector of different packages and just run the code one after another. All these packages will get installed, right? And I hope all these are already installed in your system if you had attended the previous session. If not, you need to just install it, and then you can just call all these libraries. We might be using them at different point in time during the session, but it's okay. You can just call them. Up to this, everyone is done? Yeah?
Yes, sir.
Yeah. Now, what is the next thing that I'll do? I will just load the data. How to load the data? This is the most important thing. Data is equal to, now the data that I have shared, is it a CSV file or is it an Excel file?
Excel.
It is Excel file. So if it is an Excel file, then what will be the function for reading the Excel? Read underscore Excel, right? So we just have to do this. Data is equal to read underscore Excel, right? Double quote tab. So this will show you all the Excel files or all the files that are there in your working directory. So I want GDP data. So I'll just press tab again. So it will come, and then I will run it, right? If I run it, the data will come into the environment. Okay. Is it clear? Everyone could do this. You should be able to do it because we have been doing this every day, right? Every session. Yes or no?
Yes, sir.
Yeah. So now take a look at the data. So this is the data I was talking about. We have GDP data for 5 largest economies of the world, starting from 1960 till 2023. Okay. This is the data that we have. Right? Yes or no? Everyone with me so far?
Yes.
Yeah. So basic, right? So we have got the data, and then you can check the data by first few data points by using this head data that I am just keeping. Then what we have done, it's a good practice to convert the data points into its log version, provided you do not have negative number. Unfortunately, in our data we do not have any negative numbers, right? So what we can do, we can just take a log. I'll show you one shortest and very easy, shortcut or easy method of converting the variables into log. So I'll just give this code to you, and then I'll talk about it, what we are doing. Okay, got the code. Now, please take a look at the code. I have given a name data underscore log. So it will contain the log version. And I will fetch the data from my main data, which is named as main data set, that is data. Using a pipe symbol, I will mutate across. That means I will apply log onto each and every variable that I have in my data set, except here. That is why minus here. It means except here, on all the other variables, I will apply what? Log, right? So everyone understood this particular code? It's very simple. So instead of writing separately each variable, which we had done earlier, we can also use this. This is a this is much more efficient way of doing the log conversion. Okay, everyone got it? Yes or no? Just run. So now we have a new data set named data underscore log. If you click on that, it will show you what? Here, as it was earlier, this column is not changed, and all these numbers are now what? Log version of the raw GDP data that we had earlier. Is it clear? Everyone is able to do up to this? Yes or no?
Done, sir.
Done? Everyone? Okay. So then you can view the data, first few observations, but we can always go to that particular, click that data set and see, take a look at it, right? Now, I will teach you something different, which we have not discussed or discussed earlier. That's called long format. Long format. At present, we have data in this format, that is year and GDP for 5 countries, right, for each year, right? This is a wide format. But if I want to convert this into a long format, and I will explain why we do that. That is basically for plotting using ggplot, right? So let us convert the data to a long format from wide format for ggplot. So let us first do it, and then you will understand what this code actually doing. So I'll just give you the code, and then you can just take a look at it, what is happening here. So so my data name of the new data set I have given, this is your name, any name you can give, data underscore long, because I want the wide format to get converted into long format. So that is why data underscore long, but you can give any name of your choice. And as I told you, this is same as equal sign, don't get confused. So I want to, apply pipe onto which data? Main data set that we have done after log conversion, that is data underscore log, then pipe. And then I want to apply this pivot longer function to columns equals to minus here, means it basically means to all the columns except here. All the columns except here, right? Names underscore 2 is country, values underscore 2 is log GDP. What does this mean? See, here I have given the special notes, which you can always refer later on. So columns is equal to minus here. It basically means selects all the columns except here. That means all the GDP variables will be selected. Names two is country. It basically stores the original column names, that is GDP variables, into a new column called country, right? I'll show you, then you will understand. And values 2 is equal to log GDP. It stores the actual data values, that is the logged version, in a new column called LGDP, right? Now, if you run this, please run this. Now you see there is a new data set that is called data long underscore long. Click this. You will understand what is the conversion that we have made. Can you see the difference between data underscore log and data underscore long? What's the difference?
Sir, all
Previously, we
values
had
are
a
in
wide
one
format.
column.
For each year, we had the different countries' GDP, right, in wide format. Now, what we have for each year, we have the, see, each country name. Under country, we have all the 5 countries for, and year is same, right? And in log GDP, we have the values. Now you will understand why this is important. If I want to plot a time series, and in the same plot, if I want all the 5 countries GDP to be plotted, then this format is useful. Yes or no? Why? Because in the x-axis, we will simply have the dates, that is years, and in y-axis, we will have the GDP of all the. That means what I am trying to make you understand is simply this. Say, if I do the plotting like this, this is my year, right? And this is log of GDP, right? Yes or no? So we can have one line for USA, one line for China. Similarly, we can have different lines. So for 1960, we need all 5, right? Similarly, for 1961, we need all 5. So for that purpose, I need this structure, which is a long format. Is this clear? Yes or no? Everyone understood? Yes or no?
Yes, sir.
So that's the basic idea behind this. I think you got this. So let us close this. So this is what we have basically done. Let me go back. And then you can always take a look at the long data long format, which we have already done.
So
Now
can
we'll be
you
using.
explain once again, I mean, the idea behind this long log.
That is what I was explaining. So let me repeat it again. See, what I am saying is, if you take at this, I want to plot each country's GDP year-wise, right? So what I have to do, I have listed 1960, right? And for 1960, see, look at these first 5 this thing from here to here, right? So it shows me what for 1960, what is the GDP of USA, what is the GDP of China, what is the GDP of Germany, what is the GDP of Japan, and what is the GDP of India, right? And why I want this in this format? Because year-wise I will plot it. Correct. That is what I was showing. Year-wise I will plot it. So for 1960, say for example, if I just do the annotating again, so you will understand what I am trying to say. So say this is 1960, right? So corresponding to this, suppose GDP of USA is this much, China is this much, like this 5, right? Similarly, for 1961, you will have like this, correct? Okay.
We
So
want horizontal graphs, something like
yeah,
this.
yeah. So now we can connect. So this and this will be connected. This and this will be connected. This and this will be connected. This and this will be connected like this, right? And it will go like this. So to facilitate that plotting, which is a prerequisite to do the plotting in ggplot, we had to convert this. Is it clear now? Understood? Yes
Yes.
or no?
Yes.
Yes. So this is what I was talking about. So now let us go back, and we have not used ggplot before. That's why I was explaining this, because this is something different which we have not discussed. So okay, now we will install a package called ggplot2. This is a, we can simply use plot, but it's an advanced version of plot, which is called ggplot. This has got much more functionalities as compared to simple plot, right? So I'll just give you these two codes, and I'll also give you this code to do the plotting, and you will see that we can do a very good plotting using these codes. And from that code, we will get to see a lot of things, a lot of insights we will get from simple code, simple plot. Okay, so let me just go back, and so please go ahead and install this, because it is not installed in your system. So first, install .packages ggplot. Please install it. It is already installed in my system, so I'll just run it. That means I will just load the package. Everyone done? Please install it. ggplot2. Is it installed? And then
Yes, sir.
call the library. Yes or no? Up to this?
Yes, sir.
Now take a look at this code. It is quite lengthy code, but I have given you step-by-step explanation for this code, right? If you look at here, step 1, what we are doing, we are going to, plot using ggplot, right? Now, what is the data set used for plotting? The data long, because that is required for using ggplot. What is X? See here, aesthetics. Aesthetics means you have to define what is there in x-axis. It is not labeling. You are telling Excel what is there in x-axis. Labeling is different. Labeling is just giving a name to the axis. But there are two things. R must know for computational purpose what is to be treated as X and what is to be treated as Y, because based on that it will plot. And labeling is just for, exhibition purpose. You are naming a particular axis, right? So when we are saying aesthetic, basically we are talking about what is there in x-axis. X-axis is y here, right? And y-axis is nothing but log of GDP, right? So that is what we are saying. And color is equal to country. It basically means what? Each country gets a different color, so that we can identify different countries' GDP using different, based on the different color, right? Okay. So this is the first part. What is the second part? We add a line plot using geom_line, right? So if you see the code, what they are saying, you are talking about a line chart, right? And size is equal to 1. It means if you make it 2, 3, 4, the width of the line will increase, the thickness of the line will increase. That's it. Okay. So basically you are telling a line chart. Labs means levels. So what is the level of the main, or what is the main title? It is nothing but time series of log transpose GDP 1960 to present. And what will be the level of x-axis? Year. Label of y-axis is log GDP, right? Color is equal to country. Theme is minimal. It basically means what? You do not want any grid line. You just want a simple format so that visibility improves. So that is also here mentioned, right? All these things later on also you can check that what is in step 3, which I have explained. Apply a minimalistic theme using theme underscore minimal. And finally, we have to specify where do we want our legend to appear. So legend generally appears by default in the right hand side. If you want to improve the visibility of your plot, then it is better to put the legend in the below the x-axis. So that is what we have mentioned. What is the position of the legend? It should be in bottom. Now, once I plot it, you will understand each part of it, what is legend and all those things. Okay, so let me just show it to you, then you will understand what I was talking about. Okay, are you getting a plot similar to mine? Yes or no? So this part is called legend, right? If you do not specify where it has to be placed, then it will automatically, by default, it will come in the right hand side. That might create some issue in viewing the plot properly. So that's why. Is it clear? Everyone is getting similar plot like this?
Yes, sir.
Yes or no? Now you see, this plot tells us lots of things. Can anyone tell which one is the China's GDP? Which color? You are able to
Red.
identify?
Red.
This one is China, right? Yes or no? This one is China?
Red.
Correct. Now see what is happening. Where is India? India is this one. This one is India.
Green.
So at around 1980, India and China was neck to neck, right? Yes or no? Same, na?
Yes, sir.
But now see this gap is widening day by day, right? So at around 1980, China was I think fourth, right? Third or fourth. It was behind Germany. It was behind Japan, right? Correct. But then it started picking up, and here it overtook everyone, and it is now almost neck to US, right? Yes or no? So that is how you can see from this graph, you can see how over the years China has accelerated, right, in terms of its growth, right? Okay. So for long period of time, Japan was the second largest economy. And at around this stage, there is intersection happening, right? It is somewhere around 2010. So 2011 onwards, China overtook, Japan, and now it is giving a tough competition to US, right? Okay. Is it clear? And now, and what about India? India is also going very steadily, and very soon it will just overtake Germany, right? And it will become the fourth largest, correct? And the way Japan is moving, so it can also cross Japan. That means there is every possibility that India might become in next 5 years the third largest economy of the world, right? Because you see the shape. Anyway, this is up to 2030, 2023, 2024 number is not here. And if you plot that, it will be even more closer to these two. And you see, Japan is on the declining mode, right? It is falling, correct? Because of the deflationary pressure, the growth rate is always, for last, see from here to here, you see it is almost flat, and now it is falling, correct? And for US, it is almost like a straight line. And India is also good, but US is also, almost like a 45-degree line. They're almost like a straight line. It is going up and up and up. Okay. So this is the story, and you see in one particular plot, you can see how the major largest economies, 5 largest economies of the world have behaved since 1960 till 2023. Okay. So this is the very good, what do you call, application of ggplot. Using plot and all, we have to, do it separately one by one, and in one go we can get this kind of plot using ggplot. Okay, everyone understood?
Any specific reason to use just two colors?
Which one?
Any specific reason using just two colors?
Two colors? We have 5 different colors, na?
All are red and green.
But they are different colors, right? Okay, so these colors, it by default it comes. It will by default use, if you have 6 countries, then it will use 6 different colors. That's it. Anything else? Okay. There is no specific reason for using, say, green for India and pink for say China. Just like
Sir,
yeah.
sir, up till here, if you take the original values, the graph will be the same, or since we have taken the log transformation.
Because see, it will be just the only thing is that in your y-axis it will be now a huge value, right? So in log, after taking log transformation, you are having 6, 7, 8, 10 these values, and if you take the raw version, you will have in thousands. Right? That's the only difference.
No. Oh, the graph movement will be almost same, sir. Then
almost it will be same. That means the
okay.
distance between this graph and this graph will not change, right?
Oh, okay, sir.
Is it not, right?
Okay.
So basic nature will not change, right?
Okay.
Yeah. So if you do a original version, raw version, then you won't see that green line is on the top of this line. That means India cannot surpass USA, right? Yes or no? So same scenario.
Yes, sir. And that's correct, sir.
Yeah, it is just a scaling thing, right? I'm just scaling the variables down so that it can be easily plotted in a particular within a smaller scale, right? So from 0 to 9 or 10, 15, we can plot everything. So
yes, sir. Yes,
that's the only issue. Okay, so those things are very easy to understand, but the point is from this we can see how, the competitiveness of different countries, right? Relative growth rate you can think of. So China is accelerating at a huge rate, right? So now there is some sort of dip, but it has come a long way, right? From 1982, if you just compare, this has been a phenomenal growth, right? Anyways, so that part is over, and I have given you all these explanation here as a special note, so later on you can always check all these things. Now let us get back to the important things. Now what we will do before we do anything, what is the thing that we need to do? We need to check for what? Tell me.
Stationarity.
Yeah, we need to check for stationarity, and pay attention. You can use it for research purpose. This data, the original data, right? It took me almost 1.5 years to collect the data and cleaning and all those things, right? So let me just give you these codes. I'll just give you the code and let us check whether they are stationary or not. This is a common practice that we have to do it every time, because stationarity will decide or determine which model we can use and which model we cannot use, right? So invariably you have to do it all the time. You got it? So just run the codes. So what about USA? Is it stationary or non-stationary? Yes?
Non-stationary.
Non-stationary. China? Non-stationary. What about Germany? Non-stationary. And from this shape, it is obvious that everyone will be non-stationary, right? Non-stationary. India? Non-stationary. All are non-stationary, right? That is quite obvious from this plot, right? Yes or no? All of them are kind of having upward trend. If you compare what was the situation at 1960. So that's it. Okay, everyone got this? So what is the next step that we need to do? We need to see whether these variables become stationary after first difference or not, right? Yes or no? Because that will decide whether we can use co-integration or something else that I need to do. So I'll just give you the codes. Okay. So got the codes. So we'll compute the first difference. We'll compute the first difference. So I have given D1 underscore USA just to denote first difference, because we might have to do second differencing also. That is why we have done like that. Okay. So just run this.
It says
And
some
if you
error.
Hmm?
It says some error.
No, I just run the code. There is no error. So if this is happening, you just do one thing. You run this. What is it called? There is a package. Tidyverse package. You just load it once more. This one, this package.
Which one, sir?
Tidyverse. Tidyverse.
Okay.
What about others? Others are also getting error. It should not be error.
No,
Mine
sir.
is
No error.
Huh? No error. It should
No
not be.
error, sir.
No error. Yeah. Okay. So once you have executed this command, and if you go to your data underscore log, you will have these variables, right? D1, first difference of US, first difference of China, first difference of Germany, first difference of Japan, and first difference of India, right? Are you getting? Yes or no? So these are the new variables that we have created. And this code is known to you because there is nothing new. We are just creating the first difference, right? Yes or no? Up to this, everyone is able to do? Yes or no? Akriti, are you getting, or still you are getting the error? Hello?
So this is the error. I've given in chat.
Okay. So you do one thing, you just run all the libraries once. All the libraries just do once and then do it. And even after that, if it is not working, then you have to restart your R Studio. Otherwise, there should not be any error actually. Sometimes because of some memory issues also it can happen. Or there is one more library, that is library dplyr. This one also you just run once. You have this library dplyr installed in your system. Had you installed earlier? Just try this too. I'm just giving this in the chat. If it is already installed, then just load it. If it is not installed, install it and then again run the code. So these are all tidyverse, and these are all connected for data manipulation like mutation, select, filtering, and all those things. So ideally we should get this. Okay, so now let us check after first differencing what is the story, right? Yes or no? So I have given you code till this now. So let me give you the code for testing the stationarity after the first differencing. Okay. So check what is happening after first differencing. Are we able to get stationarity for US? What's the result? Is US stationary after first differencing? Answer is
No.
no. Hello? What about China? China is also not stationary after first difference, right? Yes or no?
Yes, sir.
Yeah.
Two
What
are
about Germany?
stationary, two are not.
Is it working now for you?
Yes, sir.
So what did you do? You ran those libraries?
Yes, sir.
Yeah. So sometimes R is like little, whimsical. So whenever you have problems, so load all the packages that might help, or you have to restart. Okay, but what about Germany? Germany is stationary, it seems, after first differencing. Japan,
Stationary.
stationary.
India.
India, stationary. Right? Yes or no?
Are we doing
So,
ARDL?
huh?
Are we doing ARDL?
No, not now. For ARDL, you need some variables I0 and some variables I1, right? We'll talk about it later on. But here it is a challenging situation because till now, whatever we were, whatever data set that we had worked on, after first differencing, every time we used to get stationarity. But here it is not. So let us try second differencing and see whether USA and China become stationary after second difference, right? So, and then we will discuss what is the way out, which model we should go for, and how to address this issue. Okay. So, so this is what I mean. When you work with a real data set, it might throw a lot of challenges, which generally you won't find if you simply work on a data set taken from a book, because they have already tried and tested everything. So you are not going to get any surprises there. But with real data set, real world data set, you will always get surprised, right? And that's how it is. It should be like that only. So you need to know how to tackle those issues. So now check. We will calculate now second difference. So have I given you the code for second difference? Yes or no? Yes or no? Have I given you the code for the second difference?
No, sir.
No? This is the code I gave, na? Compute the second differences. Just compute the second difference. Okay. Now see what is similar way we have done. Now we will compute second difference. There will be two NS. Yes or no? Yes or no?
Yes, sir.
So that is what is specified here. So you are asking R2 difference USA how many times? 2 times. And you are telling that the first two will be NA. You can go back to your data underscore log and check whether it is done properly or not. You see, second difference, first two are NA. And for China also same thing, because for rest of it, we do not want second differencing, because Germany, Japan, and India, after first differencing, they become stationary, right? Okay. Here, everyone is able to do up to this. So what's the next step that I will do? I will check whether after the second differencing, USA and China, they become stationary or not, right? So let me give you the codes. Let me give you the codes. Let me give you the codes. Okay. Done. So this code is nothing new. We have already done it, right? So let me run this. So now you see US is stationary after second difference. Yes or no? Is it clear?
Yes, sir.
Yes, sir.
China is also stationary after second difference. But to do the co-integration test, all the variables that are part of your co-integration test must be I1. So I cannot, do co-integration test on, or I cannot include USA and China in my co-integration test. But I can include Germany, Japan, and India for co-integration test. But what to do with USA and China? I will talk about it later. We have some way out. But let us start with the co-integration test of co-integration for Germany, Japan, and India, which we can do because all three are I1. Up to this, everyone is clear? The logical flow, how we should proceed? Yes or no? Yes or no?
So please repeat.
What I'm saying is, for doing co-integration test, all variables must be I1. That
Yes.
means they must be stationary after first differencing.
First differencing. Yes.
So USA and China, they fail to qualify that, right?
Right.
So they
Right.
are stationary after second differencing. So we cannot directly include them. That means we cannot include
Yes, sir.
USA and China for co-integration test directly. We'll have to do something that I will talk about later. So, but straight away we can start with the co-integration test for the other three variables which are I1. Okay, is it clear? That's what we are doing now.
Yes, sir.
So I will create a new data set wherein I will select only Germany, Japan, and India. And this will be used for co-integration test. So I'll just give you this. I have just done this library DPLR just to play safe. If you, there is no harm if you load a library, but sometimes if you do not load, it might throw some error. Okay, so that is why I'm just giving it. So if this library is already installed, just call the library and run the other codes, right? So that will help. So this is already installed in my system. So I'll just run the load the package dplyr, and we will create a subsample for co-integration test. Oh, that's what I was wondering. Okay, so are you able to do it? Create a new data set. I have named it data_ci. CI stands for co-integration. It is any name that you can give of your choice. And you are basically, what is this code basically? You are asking R to select Germany, Japan, and India and create a subset from your main data set called data_log. That's what we have done. Okay. So just click on this run, and you have a new data set now, data_ci, right? Are you getting it? And if you click on this, now you have only three variables: Germany, India, and Japan, right? Yes or no? Are you getting, everyone getting this?
Yes, sir.
Yeah. Now, what we will do, we will convert this to a time series format.
Data_ci creates a subset. This
Yes,
code.
subset, a subsample. Yes. From data log, that is my main sample, I am creating a subsample using this function called dplyr. We are selecting, see, we are selecting. Okay, clear?
Yes.
Now convert this into a time series format. So for that, this is the code. I will just explain what is this code, but let me give it to you. We got the code right. So what is this code all about? If you see, data underscore CI is the name of your data set, which contains all the GDP values of all three countries, which are I1. Start is equal to minimum year na.rm is equal to true. It basically sets the starting year for the time series, right? So minimum, why minimum is used? It finds the earliest year in the data set, that is 1960. So that will be treated as the first, time series data point, right? na.rm is basically is equal to true. It ensures that any missing values in the year is ignored, which is not the case. Frequency is equal to 1. It defines the time interval, and it is 1 because we have annual data, right? So if you have quarterly data, it will be 4, monthly data, it will be 12, weekly data, it will be 52, daily data 252, like that. Okay. Is it clear? Everyone understood what we have done in this? Just run the code now. Okay. So up to this, everyone could do yes or no? So
Yes,
I have
sir.
given these notes also, so that later on you are able to understand what this code is doing and what is the meaning of each of these things in the code, right? Yes, up to this everyone is able to do yes or no? Done? Please confirm.
Yes, sir. Done.
Okay, so now what is the next thing that we will do? We will now ready for doing the co-integration test, but before we do the co-integration test, what we have to do? We have to first do the lag selection. First, we have to do the lag selection. So for lag selection, we need to use this package called vars, right? So I'm just giving you this code up to this. I'll give you, and then one by one we will see what we can do using this code, right? And I'll also explain what is going on here. Okay, so now let us go back. So please, if it is not already installed, first install. If it is already installed, then just load the library. Okay. In my case, it is already installed. Okay. Done. Lag selection. So we can use this var select. This is my data set on which this lag selection will be applied. Maximum length I have given 5 because we are having yearly data, right? So you can change it as per your choice. Type I have given a trend. Is it justified to use trend from the plot that we had seen earlier? Yes or no?
Yes.
Was there a trend or not?
Yes, sir.
Yes, sir.
There
Yes.
was a trend. So we should include trend. But you can try different options, but it is quite, obvious from the plot that there is a trend, right? So just run this and check what is the answer it is giving. Now I have given 2 codes for print selection, lag selection. I will tell you what is the difference between these 2 codes. Let me run this. If I run this one, print lag underscore selection, it will give this part as well as this part. But actually, we do not even look at this part. We just need this part. If I need only that part, then what you have to do, print lag underscore selection, then dollar only selection. You are telling that I want only this part, right? So if I run this code, it will throw only that part. See, only this part. This is what we need, right? 1, 1, 1, 1, 1. But this is something very, very interesting. the other day, I think Mayank was asking me that, sir, if I use 1, it is not taking. Yes or no? Mayank, are you present?
Yes, sir.
Yes. Now, in this case, if you take 1, it will not take, even though it is showing 1. Minimum 2 you have to take. Why? I will explain once we get the output, then you will understand why it has to be the case. Because the lag that we are specifying here, which I will be specifying here too, it is the lag before the differencing. So in Johansson cointegration test, we have some values which are at the levels for cointegration purpose. And then for the error correction mechanism, we have the first difference. That is, yt is for the long term cointegration and delta yt is for short term mechanism, right? And let me write it down so then you will understand the logic. So you have something called yt. This is for long run, right? And then you have delta yt. This is for short run. Yes or no? Now, this is this, or this also, you know, we need to, for this, we need to have the variables at its level. But for this, when I will be using first leg of this. If I write, if I use first leg of this, which will be there as one of the regressors, right? In that case, what happens? If I just keep the lag is equal to 1, if I keep k is equal to 1, I cannot compute this now. Why? Because for calculating this t minus 1, I need what? What is this basically? Yes or no? Yes or no?
Yes, sir.
So at least 2 lags are required. Otherwise, this part cannot be included. Yes or no?
Yes, sir.
Is this
Yes,
clear?
sir.
So this is the precise reason why if I put k is equal to 1, it will not work. Okay? Is it clear? But you might say, sir, then why this var select is saying lag is equal to 1? Because that is for var equation it is telling, na? Yes or no?
Yes, sir.
Correct. But
Yes.
here k means what? The lag before the, before the differencing. So to ensure that at least you have this, at least you are, to ensure that you are able to compute this, you need to have at least 2 lags. If you have more than 2, then there is no problem. But at 1, there will be a problem. And software cannot calculate it. Okay, Mayank, is it clear now, everyone? Understood? Yes or no?
Yes, sir.
Mayank? Yeah. So that's the precise reason why lag at 1 it will be. But in var, it is not a problem. And this is actually var select. You see what is written here, var select, right? And I am using the same lag length, same this criteria for this purpose also. But you have to make sure that it has to be minimum 2. Otherwise, I cannot include this, right, in my computation part. Okay. So that's the point. So now let us proceed with the other calculation or other coding part. Okay, so now we have got the answer 1, but actually we have to take 2, right? Because if I write 1, then it will won't be able to calculate. Software is throwing some error, right? Or it will show that minimum 2 is required, and I explained why minimum 2 is required. Right now, so I have given you code till this. Now we will perform the Johansson co-integration test. So Johansson co-integration test. Let us perform the Johansson co-integration test. Let me give you the codes. We are discussing co-integration in quite much in detail, simply because this is a very, very important aspect when you write research paper, because the first thing that often you need to check is co-integration if you have non-stationary variables, right? So that is why it is very, very important, and you need to understand it. Because after when we fail to test, qualify the co-integration test, then we think about other models. But first thing that we often try is this. And most of the times variables will be non-stationary, right? If they are stationary, then the co-integration straight away goes out of the question. Right? But reality is most of the variables are at level they are non-stationary. That is why co-integration plays a very, very important role. Okay. So you got the code? Just run the code.
So what is this error?
Which error? I am not getting any error.
I've shared.
Which error? Others are getting errors.
No, sir.
No. So Akriti is getting specific errors. I do not know why. What is the error you have shared? Where have you shared? In chat?
Yes, sir.
Yeah. I really don't know what is the error.
Again, I think package is not installed. Urka message.
Just check that. So it is some package is not installed, so you have to install it. Because if you see, you came late, I think, so this code
No,
you have
sir,
run.
I am here all the time.
No, but this one you have run. Just load this one first.
Okay.
Just load that, or if it is not installed in your system, first you have to install that, right? And then run the code. It should work. Okay, so I was somewhere here, right? Now I want to see whether there is co-integration or not. Based on the result, how to read this, interpret this part, because I told you in the Johansson co-integration test, this is the main part, because this tells how many co-integrating relationships are there, right? So what is the answer?
Two
Tell me.
co-integrating relations.
Yeah. First of all, R is equal to 0. Are we able to reject that? The hypothesis that there is no co-integrating relationship. Are we able to reject that? Answer is yes, because my state statistics is 52.2, and at all the levels, even at 1% also, my state statistics is more than the critical value. That means my state statistic falls in the rejection region. So I reject it. But what about R less than equal to 1? That is, at most one co-integrating relationship is there. Are we able to reject that?
Yes, sir, reject.
Yes, because this is higher than all these values, rejected. But what about this one? At most two co-integrating relationship are there. So
Again,
what
this
is
is
the case?
rejected.
But at 1% level, I am not able to reject it, right?
Right.
Yes. At 10%, at 9%, we are rejecting, but at 1% level, we are not able to reject. So we can say that there is at most, two co-integrating relationship, right? Yes or no? Is it clear? Yes. Everyone? Yes or no? Akriti, is it running now, your codes?
No, no, I was searching for that lab. I mean, I will do it. It's not working right now.
Okay, maybe. But you have the code, right? Code for that installing that particular package.
Yes. How do you spell that?
So I'll just give it to you. See, this is the package.
Okay.
URC.
URC.
URCA. First install it. Install.packages within code, double quote URCA, and then this library. The normal process of installing and loading. It should work. Otherwise, you have
But you
to.
explained right now, I missed it because I was busy searching the library.
So I'll just explain that part once. Not an issue. First, check that if it is working or not.
Yes.
It is working.
So just a
Yeah, do it.
done, sir.
Is it working now? Code, sir. Just run the code.
Sir, I have done, sir. I have done.
Okay. So I was explaining this part, that because I told you from this particular output, this part is the most important thing, because here I am going to get the answer. How many co-integrating relationships are there, right? So R
We
is
are
equal to
rejecting
0.
0.
Yeah, 0 we are rejecting, right? Then we are rejecting this one also, right?
1
This
also.
8.57 is
Yeah.
more than all this, right? Yes or no?
Yes, sir.
But what about this
Yes,
one?
sir.
This one is little tricky,
And 2.
because at this level and this level, at 10%, at 5%, I am able to reject, but at 1% I am not able to reject, right? Because this is, if I take 1% critical value, then it will fall in the acceptance region. So I will go by this particular, I will accept this hypothesis that there are at most 2 co-integrating relationships. Okay, this is what I explained. Is it clear now?
Yes, sir.
Yes. Okay. So
So have we
now,
dropped the other countries?
yes, I have not dropped. I have taken all 3.
What about the other 2?
We have not
There
yet
were
included, because we cannot include them directly, because they are I2, right?
okay. So
But there
can
are
there be a
other
situation?
ways we can include them, that I will talk about in a short while. First, up to this,
Can there be a situation where we have just one country at level 1 and the rest are at 2?
maybe. In that case, so your co-integration test is straight away out of the question, right?
We need to change the sample then.
Sample, or you have to go for other models, other types of models.
Okay.
For co-integration, the prerequisite, all variables must be I1. So there are other models also that we can think of, right? Why always, it's not necessary that every time, variables will be co-integrated. Not necessary, right? Okay, now, so up to this you are done, right? So now let us now go to up to which point we completed. This was done, this was done. Okay. So now we have to, since there is co-integration, what we have to do, we have to now run a vector error correction model, right? Yes or no? Yes or no? Up to this we have done, right? Till this co-integration test. Please confirm.
Yes,
This we have
sir.
done. Now we have to estimate a VECM, right? Vector error correction model. So if I estimate the VECM, let me give you the code. what is the R value that I should put? It should be 2 because that comes from the previous code, right? Yes or no? Right? So just run the code for Vacam and summary Vacam and then the whole.
ಅವರು ಇನ್ ಬಿಟ್ವೀನ್ ಒಂದೊಂದ್ಸಲ ಎಕ್ಸೆಪ್ಟ್ ಮಾಡಲ್ಲ ಕ್ಲಾಸ್ ಹೇಳ್ತಿರ್ತಾನಲ್ಲ
Yes, Manoj sir, please mute yourself. So some feedback was coming from your side. Okay, so now so what is the result that we are getting? Are you getting similar result as mine? Yes or no? Hello?
Yes, sir.
Yes, yes. Now you see, in this case, when look at this equation, you will understand what I was talking about, right? See, this is my first. We have taken first difference of Germany, right? So this is basically your delta y, delta yt, delta yt, first difference, right? And then these are the two error correction terms, Then this is the first leg of first difference. That is delta yt minus 1. This is also the first leg of Japan's first difference. This is the first leg of India's first difference. Okay? Right? And data is equal to this. Correct? Now, so this is the equation that I was talking about. You understand? Now you
What is
understand.
minus 1
like
here?
at least- Huh?
What is minus 1 here?
Minus 1 means it is saying, by default, it is dropping the constant, right?
Okay, okay.
Okay. So now, in this case, you see what is happening here. These two are constant. These two are statistically significant. That means the error correction terms are statistically significant, but short-term impacts are not statistically significant. It basically means there is a long-term relationship between these variables, but short-term dynamics is not statistically significant. Now, this part you need to understand a little bit. See, ideally, a positive coefficient of ECT2, it is very difficult to defend this if you are writing in a research paper, if you are putting this in a research paper. Why? Because I told you the other day, ideally, to restore equilibrium in response to a deviation from the equilibrium, your coefficient of ECT must be minus.
Yes.
Right? So if it is minus, then it is stabilizing. That means it reverts back to the long run equilibrium. If it is plus, then it is destabilizing, right? So it is very, very difficult to, one side you are telling that they are cointegrated, but if you are saying that the coefficient of the error correction term is plus, then it is actually economically, it means it is deviating from the long run equilibrium, right? So that is why best way is to report the minus thing only, because that can be defended. Say for example, many times when we run regression equation, our constant term constant term may be statistically significant. But do you report that in research paper? Answer is no. Yes or no? Why? Because the constant term may not make any economic sense given my data set. Because constant term y is equal to a plus bx. What is that a? When x is equal to 0, right? Yes or no?
Yes, sir.
Yeah. Now in your data set, there is no value which is where x is equal to 0. So does it have any economic meaning? And your regression might show that the constant is statistically significant. So same way, if you are having the coefficient as plus, and if it is statistically significant, it is very, very difficult to defend that, simply because it economically means, instead of reverting to the long run equilibrium, it is going even further from the long run equilibrium. Right? Is this point clear? Understood? So
Sir, but sir, ECT1 is negative and it is bigger than the ECT2. So processes may a bigger process of equilibrating mechanism can bring it back to the long run equilibrium.
no, but that is fine. That is always fine. But this, what I'm saying is, economically, it is very, very difficult to defend. Right? That is what I'm saying. Okay. So there might be a scenario, say for example, in this case, this is bigger than this, but it might so happen that the plus is bigger in magnitude than the minus. It is also possible. Many times we get that.
Yes, sir.
Yes
Yes,
or
sir.
no?
Yes,
So
sir.
those are difficult to defend economically. That
Yes,
is
sir.
what I'm saying. So ideally, the best thing is it should be minus, because when it is minus, then it basically means that it is reverting to the long run equilibrium. Okay, that's what I was trying to make you understand. Is that point clear? Yes or no? And if you have to report it, then you have to tell that this is the rate at which it is deviating from the long run equilibrium, because this is a sign of destabilization, and this is a minus is a sign of stabilization, right? Stability. Okay. Is it clear? Understood? So what is the conclusion that we can draw from these numbers? We can draw that these variables are co-integrated. That means they have some long run relationship, but short term dynamics are not statistically significant. That means any short term deviation, short term fluctuation in any of the regressors are not able to impact the short term fluctuation in the dependent variable. That's what basically this means, right? What about the other thing? In case of other thing here, so this is I think much more sensible, because only this one is statistically significant, which is negative, right? And for this again, both positive and negative are there, and in this case you see this positive is higher than the negative, right, in
Yes, sir.
magnitude.
Yes, sir.
I don't know. So that's what I was making, that point I was making. So ideally we would like to report this mostly, because this is you can always make some economic interpretation, but that is actually going against that basic concept of the long run equilibrium, because it shows deviation from that, right? Okay. I hope this is clear, right? And this problem we generally do not face when we do the Granger and causal Engel and Granger case, because there we have only one co-integrating relationship, right? Yes or no? So either you say plus or minus, and in most of the cases we get it -1, right? Now you might say, sir, is it happening because of some model misspecification? Maybe. So if we improve, then we might get only minus, or if at all plus is there, that won't be statistically significant, right? That is the ideal situation. But as I told you, when you work on real data, ideal situation may not be there, right? So anyways, I hope these points are clear to everyone. Yes or no?
So what conclusion do we draw from this output, the combined output, entire output?
So combined output, you can say that these variables are basically having some sort of long run co-integration or long run equilibrium. They are co-integrated, but in the short run, they are not showing any statistically significant relationship. That's what we can draw conclusion from this. And I will just explain that there are so many other things that I can do to improve this model. Okay. So that is what we are going to discuss now. That is quite obvious from the result, right? Yes or no? Because we are getting the error component terms significant, but other short term fluctuation, these terms are not significant anywhere in all three cases, right? So the broader conclusion that we can draw that they are having some sort of co-integration, but short term relationships are not statistically significant. Clear? Is it clear? Yes or no?
Yes, sir.
Now you see there are so many flaws in these models, and I cannot be proud of this model simply because, can you tell what are the flaws in this model? Anyone? What are the flaws in the model? I am
The way
trying
we
to
selected co-integration tool.
know what are the problems? Because what is the variable here? GDP, right? So are we are saying that GDP depends only on GDP of a country depends only on the lagged values of GDP of that country and lagged values of GDP of other countries. That's what we are basically saying. Yes or no? Yes or no? See this equation. What is this equation?
Yes, yes, sir.
But is it the case? GDP of India, is it only depending on lag values of GDP of India and lag values of GDP of China, Japan, Germany, and the other country? In this case, only those two countries. Is it the case? It's not the case. You have to include some exogenous variable, the way we include control variable in our finance related research. That means you have to have at least, is there any external shock? Say, for example, I have taken data from 1960 to 2023. There are so many global shocks that have happened, and those might have impacted GDP. Have I controlled them? Answer is no. There are certain macroeconomic variables that have direct impact on GDP, like inflation and interest rate. Have I controlled them? Answer is no. Are you getting my point? What I'm talking about? Yes or no? So these are basic things that I need to include in my model. I need to control them. Then only I can make some sensible or defendable output. Otherwise, it is not, because this model is very restrictive in that sense. Is it clear? Because I am just presenting GDP as a function of its own lag and the lag of the other country's GDP. Is it clear? So from this comes the concept of what? Including the exogenous variable into your model. So what is endogenous variable? Endogenous variables means, in simple term, here see all the variables, that these three variables are treated as endogenous. It means I'm expressing GDP of India as a function of GDP of India's lag, GDP of Japan's lag, and GDP of Germany's lag, right? So it is endogenous, dependent on others. Similarly, again, I'm just expressing GDP of say, what is the other country? Japan, as a function of GDP of other countries. So that is also endogenous, right? Similarly, GDP of Germany is also expressed as a function of GDP of other countries, right? So all are endogenous. Means, in simple term, you can remember like this: endogenous means dependent. So we are saying that variables are interdependent, right? But what is exogenous variable? Which is impacting these variables, but they cannot be written as a function of other variables, right? Those are called exogenous variables. So I might say some shocks, say global financial crisis. That is an exogenous variable that impacts GDP. but GDP cannot impact them, right? Yes or no? Is it clear? Understood? Are you getting my point? So in those cases, I need to, if I really want to, improve my model, I'll have to include some exogenous variables in the model which can impact GDP, right? Otherwise, I cannot improve this model because as it stands, it is very, very restrictive because I'm saying GDP is only a function of lag of that particular country's GDP and lag of other countries' GDP, right? Okay. Another important thing, you see, I have excluded two most important countries. Don't you think, China is a factor? Because how much GDP India makes, that depends on how much GDP China makes. Yes or no? Do you agree with me or not? Yes or no?
Sir.
Because all industries, if they go to China, India's GDP will go for a toss, right? Yes or no? And that is the case. China is being the manufacturing hub. It is taking all the FDIs into that particular country. Similarly, US being the largest economy, how US GDP is moving, that is also going to impact India. I have not taken them into consideration, right? I could not include them simply because they were not integrated. They were not co-integrated. But those are the two major forces, right? So obviously, India's GDP, or for that matter, Japan's or Germany's GDP, definitely depends on the GDP of China and USA. I have not included them in the model. How come I am explaining that or expecting that this model would be defendable? It won't be defendable, right? So the point is now, how do I include them? Understand the reasoning that I am putting out here. So how do I include them? I can include USA's GDP and China's GDP as exogenous variable, provided, but I cannot include them in their level. I can include them after making them stationary. I can include them after making them stationary. That means the second difference of US GDP and second difference of China's GDP can be used as exogenous variables and included in the model. But they will never be. That means China's GDP will never be expressed as a function of GDP of other countries. Similarly, US GDP will never be expressed in this particular system as a function of other country because they are being treated as exogenous. So this is what I was making, that this is the alternative that we have. Since we could not include them in the co-integration because they were I2, but we can convert them into stationary and add them in the model as exogenous variable. So that is what is the next step that I'm going to do. Okay, is this clear? Understood? So this might improve my model to some extent, right?
Sir,
Because
whenever we include exogenous variable, we have to make them stationary first of all.
Yes, obviously, because when I am putting, I will be putting them in which equation? I cannot put them in the long run equation, right? Yes or no?
Right, sir. Right.
Because they are not co-integrated. So I'll be putting them in which equation? In Vacam. Vacam. And Vacam is expressed as what? Delta YT, right? Yes or no? Delta YT means what? It is in the stationary version. First difference is the stationary version. Yes or no?
Yes, sir.
So if you have your dependent variable as a stationary variable, then regressors must be stationary, right? So otherwise it goes against the beyond principle, goes against the basic principle of the stationarity, right? So that is why we cannot put them, we cannot just simply take the GDP or log GDP of USA and log GDP of China and put them as exogenous variable. We'll have to take them in their stationary form, right? Is this logic clear? Everyone understood this? Yes or no? Okay. So what basically we are saying, since they are not co-integrated, I'm saying that in long run, they may not have relationship, but the short run fluctuation in the GDP of a particular company can still be impacted by the short run fluctuation in the GDP of USA and China. That's what we are basically saying. And I am treating them as exogenous variable, right? After converting them into stationary. Okay. This might improve my model to some extent, right? So let us see whether it improves my model to some extent or not, and then we will proceed further how to improve the model even further. Now you see how much rigor is required to come up with a good research work. Simply the things that are explained in the book, those are too basic and too elementary. If you write paper using those things, your paper will never be accepted. And I will show you how much rigor is required, and it's really challenging, right? So you have to think, and how do you make your result credible or defendable? That is very, very important. Because if you simply say that GDP is a function of lag GDP of that particular country and lag GDP of other countries, you are missing out lot many things, right? So, and if you miss them out, they sit in the error sum, right? And that will create problem because your model will never be defendable, right? So you'll have to bring, as many information as possible into your model, which will improve your the model's explanatory power, or it will help you meet the assumptions of the model, right? So we have not yet gone into the diagnostics, right? So after doing all these things, finally we'll have to see that whether we are able to meet those assumptions or not also, right? So but from this we can easily say that this model can be improved further. There are lots of scope for improvement. Okay, are you with me? Yes or no? Yes or no up to this? Yes or no?
Yes, sir.
Yeah, so let us proceed now. So what is the next step that we will do? We will now introduce exogenous variable. So in simple term, exogenous variables are those variables which are not treated as dependent variable in this var structure, right? That means they will not be shown. They will at most be as a regressor. They will never become a regressant, right? That is what the simple thing that you have to keep in mind. In case of India, India, Japan, and Germany, these three countries' GDP, they are treated as regressor as well as regression, right, in different equations. But once you treat a variable as exogenous variable, it will only be regressor. It will never become a regression. That means it will only be the predictor. It will never become the predictant, right? That's the point that you have to keep in mind. Okay, so that is the basic definition of exogenous variable. Okay, is this clear? Everyone understood this? Yes or no? So let us now do it. So what we'll do now, let us define this. Let me give you these codes to you. Right. Got the code? So see what I'm doing. I am defining, I am creating a particular data set for only the exogenous variables. And see the code what I have done. I am selecting what? Second difference of USA and second difference of China. These we have already created. Why? Why I have taken this second difference of USA and second difference of China? Can anyone tell why?
Because it was
Because second difference,
stationary.
they were stationary. Yes. I cannot just take them as simply log value, that is the at level, right? So that's what we have done. So just run the code. Okay. Now, when we do Johansson test, now we add this sum, which was not there earlier. This is basically we are adding some exogenous variables. We are adding some exogenous variables. Okay. We are adding some exogenous variables. Is it clear, everyone? Yes or no? So just run the code. And see what is happening. Am I able to reject the zero co-integration? Yes or no?
Yes.
So the result?
Yes.
And same conclusion we can draw that there are at most two co-integrating relationship. Yes or no?
Yes.
Yes. So let us proceed. So now we will go for vector error correction model. So just run the code. Print first summary. This one you can delete also. This is not required because I am interested in the complete thing, not only on the equation. Okay. So what is happening here now? See, what is happening? Now you see all the co-integrating terms are statistically significant, right? So in a way you can say there is slight improvement in the result, right? Yes or no? Because still there is further scope for improvement. Why? Because I have left out so many other exogenous variables, especially the external shocks, like oil crisis, financial crisis, the crisis that happened in 1987, the Euro crisis, the Asian crisis, right? COVID, right? Then Ukraine war. There were so many external shocks that impacted global GDP, and every country's GDP got impacted. Do I need to factor them in? Yes or no? What is the answer? Answer is yes, because my time series spans from 1960 till 2023. I need to control for all the external shocks, major external shocks that were there during this time period. If I do not do it, then the impact of those will be sitting in the error term, right? So basic principle of regression, which we discussed in panel, right? So that will create problem. My model will not be defendable. I cannot defend the outcome. Okay. Not only that, even after doing that, still there is scope for improvement. Suppose I include all of them as dummy variables in the exogenous part, right? Because what is the reasoning that I am giving? That they are impacting my GDP, but GDP is not going to impact them, right? So they are exogenous in nature. We can also include some of the other macroeconomic variables that influence GDP, like you can have crude oil price, as or better is inflation, which is likely to be stationary, and you can include interest rate, which is also likely to be stationary, right, as the exogenous variables. And thereafter, if you run the model, you are more likely to defend that, because you are kind of plugged in all the possible things. You will never be able to plug everything in, but as long as you are able to make the errors kind of random, they are not anymore correlated, then all these things will be, the model will be defendable. And if you do not do them, they will be sitting in the error term, and because of that common impact, they might create autocorrelation problem, right? So we'll talk about all those things in diagnostics, but for now, let us proceed. So what we have to do now to
So
improve this model
normally,
further?
which interest rate do we take?
Huh?
Which interest rate do we take?
Good question. Say the average interest rate in the world, right? We cannot take interest rate of a particular country, right? Yes or no? Average inflation of the world, right?
So
For a
suppose
particular
if
country.
it is India's data and I have one is GDP and the other one is say interest rate or say suppose money supply, these
Simple.
changes frequently. So can we have one data which is yearly and the
That
other?
is what yearly average you have to take, basically, right? Because we are taking the GDP for the year, right? So yearly average you have to take average inflation rate in a particular year in the overall economy, means basically the countries that you are including in your model those countries' average. Ideally, that should be taken. But for interest rate, basically you can take average, rates by Fed, because the central bank of USA, whatever the interest rate that they determine, based on that every other country changes their interest rate. Yes or no?
Yes.
Correct. So like that. So ideally it should be average.
Mm-hmm.
Correct. But it needs to be included. Why? Because on that they will impact the GDP of these countries. If you do not include them, they will sit in the error term and create problem. Error term will be having some trend, or it will show some correlation, right? And which is against the basic principle of your any regression for that matter. Because at the end of the day, you are doing regression only in different forms, right? So that is the point. That is the catch, and that is why it is so challenging, right? Because we most of the times we do not even go for the diagnostic check and all, right? And most of the times we will fail in that, right? So anyways, but we should try and improve it to the extent possible. Okay. Next, so now what is to be done? Now we have to create different dummy variables for different crisis, okay, or different shocks, external shocks. Now we will do it step by step. First, we have created dummy variables for two things. One is the 2008-9 crisis, and the other one is your COVID. Okay.
Sir,
And we will.
sir, I have a question. Do we
Yes.
directly decide that which crisis we are going to take, that is part of our research paper, or do we need to check the structural break or something like that?
No, I have not yet gone into structural break. Okay.
Okay.
Now here, so there are two types of dummies. One is event dummy, the other one is structural break dummy, right?
Right.
So if I will show that structural break also. If I treat that 2008-9 as a structural break event,
Okay.
then the dummy will take one value from 2008 till 2023 and 0 before 2008, right? But
Yes.
if I treat them as just an event, then for 2008 and 9 it will be 1, for rest of all the years it will be 0. So there is a difference.
Okay,
Right?
sir.
As of
Okay.
now, I'm just treating them as short-term shock.
Okay,
I'm not
sir.
saying that because of the crisis there was a structural change, the way GDP got impacted across different
I
countries.
got it,
Okay,
sir. I got it. I got it.
got it. So question is
Yes,
very
sir.
much valid, but as of now, I'm just looking at the short-term shocks.
Yes, sir. Now
Right?
I'm clear with the difference. Yes.
Yes, there is a difference, and I will just include that also and show what is happening. Okay, so and you have to more than the any test deciding where is the structural break and all, it should also be theoretically defendable from the literature, right? And it is a well established fact that the financial crisis will change the way the trade and commerce happen today vis-a-vis how it used to be before the crisis, right? Now we have become much more conservative, right? Yes or no? So that could be a reason. But anyway, I'm coming to that. But let us now do this. Now, so I'll create what I'll create. I will create two dummies, one for COVID and one for
Pravesh needs to.
yeah.
Pravesh mic is open.
Oh, please mute it. He may not be present here. Might have gone for lunch. This is the beauty of online class, right? You can do so many things simultaneously. Right. So now I have given you the code, right? So just as a precaution, you can run this library and then I am creating two variables. One is dummy underscore 2008, which will take the value of 1 for year 2008 and 9. Otherwise, it will be 0. This is what it basically means. This code means. Similarly, dummy underscore COVID, which will take the value of 1 for 2020 and 2021. Otherwise, it will take the value of 0. Right? Just run this. So it got created in data log, right? It got created in data log, right? So just data log. So go to data log and check whether it got created or not. Yes. So you see
I
for
haven't understood the code.
I'll explain. 1 and 0, 1 and 1. So this is 2008 and 9, 1 and 1, and for rest of it, it is 0. Right? Is it clear? Understood? Okay. And COVID dummy for 20 and 21, 1, for rest of it is 0. So the code has worked exactly the way I wanted or we wanted it to work. Okay. So the code is very simple. I'm
This
saying, what is this? This called? This is a logical operator.
okay.
It tells whether in year there is a column called year, right? Yes.
Mm-hmm.
So if in that column, if 2008 and 2009 are found, then against those years, 1 will be written. And for columns or for rows where these two are not found, it will be substituted by G. That's what it basically means. Okay.
Oh.
Understood?
Mm-hmm.
The same way here also, in this column here, right, under this column, if 2020 and 2021 are found, then
Then
against those years, 1 will be written. In other years, against other years, 0 will be written. This is what it basically means. Okay.
okay.
Understood?
Yep.
And it's a very powerful thing because, see, dummy variables can change the game altogether in your research, because a lot of qualitative aspects we can include in your model using dummy variables. So learning how to create dummy variable is very, very important, right? Okay. So done. And I just cross verified that it was done perfectly and as we wanted, right? So now you can always argue, sir, should it be 2007, 8, 9? So you can always add that, not a problem. Should this be 2020, 21, and 22? That also you can add. One more add here you can add. So you can always play with those things and try and improve that. Okay. So up to this, everyone done. And now what we'll do, now again, we will define the exogenous variables. Now it is no more only these two. I will have these two plus these two, which we have just created. Now the exogenous variable will be second difference of USA, second difference of China, then dummy underscore 2008 and dummy underscore COVID. Everyone understood now? Now we'll have 4 exogenous variables. Yes or no? Hello?
Yes, sir. Yes, sir.
Yes. Now I'll just give you these codes because we have to go a long way. We need to economize on the time that we are spending on these codes, right? Because they are not any different, only now different variables are there. That's it. Now, so first define the exogenous variables. Okay. So now these exogenous variables will have 4 variables. Can you see that? These 4 variables which we created, correct? Is a subset of data. Now run this Johansson cointegration and so same conclusion we can draw that there are 2 co-integrating relationships. Yes or no? Yes or no?
Yes, sir.
Yeah. And we can run the vector error correction model, right? And then we can just see the output. I can delete this because this is not required. This is already there in this. Okay. So what is happening here? Let us see what is happening. There might be some improvement. Yes, it seems there are some improvements. Okay. So the level at which now everything is star, right? The statistical significance improved. Yes or no? Previously, some of them were dots only, right? Yes or no? Some improvement has happened, correct? All the co-integrating terms are statistically significant now, right? Some improvement has happened. Definitely, it has to happen because we are bringing some information from the error term and putting them into the model. So there has to be some improvement, provided they have some, information in them. And definitely, these things do have some information content in them, right? Okay, are you getting the idea what I'm doing and how to improve your model? Yes or no?
Yes, sir.
Yes. Now see how much painstaking all these things are. Now you simply run a regression and think that it is going to be accepted as a research paper. Not going to be the case, right? Next, what is how much we have done now? This we have done, and this model also we run, right? Yeah. So now what we'll do, as Parminder ma'am was asking, can we treat 2008 as a structural change than just simply as a short-term event, right? That impacted the output GDP of 2008 and 9. If I treat, it as a where have I done that? Yeah, here it is. I have done till this, right? This point. Yes or no? This point till this point we have done. Right? So now what I'm doing, I am treating both these events as a structural change. That means COVID as well as 2008 crisis. But ultimately, I have treated only, while doing the modeling, I have treated only this as the structural dummy, not this. But just to be on the safer side, so that I can experiment, I have created both structural dummy, right? So let me give you the code, and then we will understand what is going on here. Okay. Just take a look at it. So take a look at the code. What I have done. Name of the variable is structural dummy 2008. Now I am saying from, if the year is greater than or equal to 2008, then it should be equal to 1. Otherwise, it should be 0. This is what I was talking about. Yes or no?
Yes, sir.
Or no? Yeah. Similarly, for COVID, if the year is greater than equal to 2020, then it should be 1. Otherwise, it should be 0. Okay? Is it clear? Run the code. Run the code. Right?
This code will find out if there is a structural break.
So here we are implicitly assuming there is a structural break.
We
Because
don't find it.
we can find it, but even if you find it, there has to be theoretical justification, right? And it is a well-established fact that the economies of different countries got structurally changed after 2008 financial crisis, because the volume or the magnitude of that crisis was so much that because the risk-taking behavior reached at its pinnacle or the highest point in 2007 and 8, right? And if those who studied a little bit of derivatives and risk management, you must be aware that companies that got collapsed had debt equity ratio like Lehman Brothers and all. They had a debt equity ratio of 32:1. That means for 1 rupee the owner contributed, they borrowed 32 rupees. So you do not have to be an expert to understand that this business is going to collapse, right? But they did not have that leverage overnight, right? Over the years, it happened, but no one, stopped them from doing it. Means regulators. But after that crisis, regulators become much more, stringent. So now we have much more managed or constrained risk taking, right? So that is what we mean by structural change, the way we behave as a country, as a nation. So that got changed, right? So that's the point here. We can always use some test to figure out where is the structural break, but even after you do that, there has to be a theoretical justification for that. If your test suggests that the structural break happened somewhere in 2013, 11, then was there any event that had some impact? If that is not there, then it cannot be. So better to decide the structural break based on the literature. That is always defendable, right? Okay, that's the point. Did you get my idea what I was trying to put across? Yes or no?
Yes.
Yes. So now, what is the next thing that I will do? I will now redefine the exogenous variables. What I have done, I have deliberately dropped COVID, and just you can always try both of them and see what is happening. I tried, but this one I preferred because this was giving much better result. So what I have done, instead of both COVID and 2008 as structural break, I took only 2008 as structural break. Why? What is the logic? Mathematical logic. Can anyone tell why did I not consider both of them as structural break? Because when I'm using 2008 as the structural break, anyway, every year after 2008 will be 11111, right? And COVID happened in 2020, so it is kind of getting submerged into it, right? Yes or no? Yes or no? Did you understand what I just said?
So please explain again.
What I'm saying is you can use both, but I just wanted to avoid to some extent the duplication, but you can still do that. I tried both and this was giving much more better result, because since this event happened before 2020, so anyway, even for 2020 onwards also, because of this, the value of that particular year will be one only now. Because if I use 2008 as a structural break, then for every year after from 2008 onwards, we'll be having one, right?
Yes, sir. Yes, sir.
So that includes 2020 also,
Right.
21, 22 also, right? Yes or no? So I do not know if I include both, will that improve? But from basic mathematical sense, I think this is much more efficient way of doing it, right? Okay. So you can include both and check whether result is improving or not. That's the point. Okay, so just run this. I have given you this code up to this.
So
Yes or
that
no?
means we can only include one structural break if it is 2008. Then after that, Euro debt crisis happened or any other crisis.
So in those cases, I can still use them as event, not as structural break, right?
Okay, sir.
We can use them as event, not as structural break, right?
But even if we are going to
And
use them as
it logically speaking, structural break does not happen frequently. It has to be, a crisis has to be humongous, right? So whatever shock that I talked about, out of those shocks, only 2008, 7, 8, 9, that crisis was huge. Okay. See, the other crisis like, what do you call the debt crisis, European debt crisis, oil crisis, and all those things, they were not something of that particular magnitude. So structural break happens very rarely. Right? So better to have only one structural break, and other shocks you can include as event dummies, not as structural dummies. Is it clear? Yes or no?
Sir, even if we are going to take it as event, I want to include, let's say, Chinese bubble or Euro debt crisis. I am going to give it as one, and already that will be one after structural. If we are going to incorporate structural break as 2008, so the value will be one. And then if I am trying to incorporate Chinese bubble or Euro debt crisis or Russia Ukraine COVID, it will be one only. So I
No,
mean,
but it is treated as a different variable now, because see what there could be a multicollinearity problem if you
right.
use every variable as a structural break, right? Because for a particular portion of the time series, it will be exactly same, right? But if I use it as a dummy, event dummy, then only for that particular year it will have one. Rest all will be zero. So still there will be some variability. Variability will be much more. That's the basic idea. But what you are saying, that is also fine. That is why I have not included both COVID and this as a structural dummy. But still you can use COVID as an event dummy. That's what I'm saying. Okay.
Just for clarity of thought, sir, then it is better to include event breaks rather than structural break.
No,
Event
that is
dummies.
event dummies for smaller shocks.
Okay. Okay.
But when there was a structural break, you have to include it, na?
Okay.
Because financial crisis was huge. It changed the way the economies, started to function, right? So there you have to use structural break. The other shocks you can still use as event, right? Okay, that's what I mean. Fine, understood?
Yes, sir.
Yeah.
Can I say something?
Yes.
Sir, we cannot use two structural break in one study, right?
Generally not recommended. We can use, there is nothing wrong. If your model improves, you can always do it. And if you can defend your assumptions, you can always use it. I think there is nothing called right or wrong. That's what. If it adds to the model's explanatory power, you can always do it, right? But
Creating dummy would be difficult, sir, in that case.
no, more than that, creating dummy is not the problem. Problem is theoretically, can you defend? Like, can you say that because of COVID, after COVID, and see, if you take the stock market, COVID shows a post-COVID, there was a V-shaped recovery. It means what? We have reached where, before COVID started, where we were there, we reached that stage in 6-7 months time. It means what? COVID did not have structural base.
It was a correction for a short time only.
If had it been structural break, then it would have taken, still today, we would have reached the previous level, right?
Got the point, sir.
Getting my
Got the
point.
Yes, sir.
Say, for example, before COVID, we were, we were generating, we were growing at say 10%. And after COVID, suppose all of a sudden we started to, grow at say 5%, 4%. Then we say that it had that kind of impact. But if you see that only that year it got impacted, but from next year onwards, again, we are back on track. Then it cannot be said as a structural break, right? Is it clear? Understood? So, but for financial crisis, the impact was much more prolonged, right? And it changed the way we behaved, right? That's why it is called structural break. But again, there is nothing called right or wrong. If it improves your model, you can always do that. Okay, but you have to defend it, theoretically in the paper. That why are you using this as a structural break and why not as a structural break, right? Okay. So now let us.
Sorry. Although we have to tell them that we have identified this as a structural break. So, or in our data set, we could only identify 2008 as a structural break. So we need to give, we need to verify that with the test. So, I mean, there are different tests of for.
That's always there. That is always there because that
Yes,
is
sir.
not the discussion today. That
So you'll be discussing. No, that is what.
we'll discuss. We'll discuss. That is not a problem. But more than the test, theoretically, you should be able to defend. That is what it is.
Right,
Right?
sir. Right.
Okay. We'll discuss that. Is not a big deal. Okay, but understand how, you can improve the model, the way, the thinking, sequence of thinking, how you should think
Yes,
to
sir.
improve the model. That is more important. That is
Yeah,
what I'm
that's
saying.
clear, sir.
Excuse me, sir.
Yes.
I don't have much idea about structural change. What I all know is just the definition. So whatever you have explained till now and whatever the discussion has happened, I haven't understood anything gone over my head. I hope
Simple
I am
thing.
not wasting anybody's time.
Structural change means there is some fundamental change the way you behave. Right?
Yes, that I know.
So it basically means 2008, 7 and 8 would be considered as a structural break point simply because the risk culture changed after 2007 and 8. Before 2007 and 8, people used to take, they used to be very, very aggressive on taking risk. And because of that crisis, regulators became very, very stringent. And now, all of a sudden, from aggressive risk behavior, we have started to become what? Conservative in terms of risk taking, right? So that is an example of structural change, right? But COVID not being directly related to the finance domain or economics domain, it started with what? Health crisis, right? Yes or no? So that did not change structurally the way economies function. That's what I'm trying to make you understand, right? And financial crisis being a financial or macroeconomic driven crisis that changed the way economic functioned before and after. That's what actually, right? This is basically the definition of structural change. Okay.
There are two variables that you have created. One of the structural dummy and the other one of COVID and 2008. And so does R is able to recognize what are we doing 1010?
Why not? It is recognizing. See, you are talking about this code. Which code you are talking about? This
Yes,
one.
sir.
It will be, see, you go to data log. Where is my data log? See, structural dummy, 2008. So from 2008 onwards, it is all 11111, right? Yes or no? This is what I told R to do.
Yes.
What about COVID? From 2020 onwards, it should be all 1111. Okay?
Yes, sir.
That's not a problem. Coding is easy. I'm talking about defending theoretically whether it is a structural break or not. That is more important, right?
Now, next we are writing define the exogenous variable. What is happening there?
Yes. What is happening where? In this.
Define the exogenous variable. Huh?
So now we have, I created these two, but I have taken only 2008 as the structural dummy, not the COVID. Right? Now we have three. Okay?
And why do we have just USA and China?
This is something very funny. After discussing so much, you are asking this. Why only these two? Because they were not included in the co-integration, being I2, right? Yes or no? Recall.
Yes, sir.
Yes. And now
Today's
some of
lecture is a bit difficult, sir.
no. These two were not included in the co-integration simply because they were I2, right? Yes or no? So
Yes,
to
sir.
include
Yes.
in the co-integration test, they must be I1,
Hmm.
right? But we were arguing that these two being the world's largest economies, they definitely impact the GDPs of other countries, right?
Hmm.
So they need to be included in the model. But I cannot include them as endogenous variables because they are not co-integrated. So what I can do, I can include them as exogenous variables. Right? That is what we have done. Correct?
Yep.
Is it clear now?
Yes, sir.
Okay. Understood. Okay.
And then once you use the word event, what was that?
Event means when we create event means I am just treating it as a short-term event. That means if I treat 2008 as a short-term event, then event dummy will take 2008 is equal to 1 and 2009 is equal to 1. For all other years, it will be 0. But if I treat it as a structural break, then from 2001 on 2008 onwards, all the years it will be 1. And before 2008, it will be 0. That means I'm saying that behavior changed from 2008 onwards. So that's a different, phase, right? And if you are treating it as an event, then for only 2008 and 2009, it will be 1. Rest of it will be 0. Okay. Clear? Understood?
Yes.
Difference between event and structural.
Yes, sir.
Okay. Now, let me now proceed with what is the next thing that I wanted to discuss. Okay. So, I have run this code. Yes. Now, have I given you this code? Which one I have given? This was given to you? This was given? No, right? Okay. I have given you the code. Just check now what is happening. So run this code. Okay. So what is the result you are getting? Same result, 2 co-integrating instigators. And
Yes, sir.
yes, so if you run this, make them run the summary and finally get the output, right? And see the output. Okay, what is happening? Here we see the structural break is statistically significant, right? This structural dummy is statistically significant. Yes or no?
Yes. Yes, sir.
Yes, sir.
So it is adding more to the information, right? Now, what else we can do? These things we will do in the next class. I can create other, shocks as dummy, like oil crisis that happened 73, 74, 79, 80, date crisis that happened in 1982, then Black Monday, that is stock market crash in 1987, then Asian crisis that happened in 97 and 98, then dot-com bubble that happened in 2000, 2001 and 2002, then Euro crisis that happened in 10, 7, 12, then Ukraine war that happened in 22, 23. If we include all of this, will it improve my model? Obviously, it will improve my model. Okay. So we'll discuss these points in the next class. But I hope I could give you some understanding of how to approach it. And if you complete this and top this up with, say, including 2 more exogenous variables like interest and inflation, then it can go for at least for a B level paper with same data set, with same analysis.